So this video is a review along with an application, and to follow along you're going to need to download the problem associated with it. So go to the link below the video and click on the link and download the Word document that has the problem. The problem basically says that the US is a world leader in beef production. I think that's accurate, but unfortunately cows produce a lot of greenhouse gases. That's also unfortunately accurate. Assume for the purpose of the problem that there's a constant $4 marginal external cost associated with beef production per pound, and we're given some supply and demand curves. So before I go on to answer any questions and analyze this situation, I'm going to write down all that important stuff. There's a negative externality from production, so negative P externality, and it's $4 per pound. My demand curve is given as 12 minus P, and my supply curve is P minus 2. All right. So before we do anything more, also, I could, draw a graph, try to get an analysis of this situation. It turns out later in the question it's going to ask me to make a graph anyway. So I'm going to just do that to kind of organize myself to start off with. So let's draw a graph right here. We have our axes, Q on the horizontal, this is in pounds, P on the vertical. It's actually just anything that's in dollars per pound you can plot on the vertical. It's not actually just the price. And I can draw in my demand curve, but before I draw in my demand curve, I'm going to need to invert it, right? We don't actually plot Q against P with Q on the vertical, so I can't plot it in this form. It's kind of in a useless format where the X variable Q is on the left-hand side. But if I rearrange it to get P on the left-hand side, then I have P equals 12 minus Q, and that's something I can plot. Now it's in slope-intercept form. It has an intercept of 12, so right here is 12, and a slope of -1. So this intercept is also 12, and that's my demand curve. I can do the same for supply, and I get P equals Q plus 2. So this is going to have an intercept on the P axis of 2, a slope of 1, and I'll label that supply. All right, so the first thing I'm going to need to do to analyze this externality, and the question asked me to do, is find my marginal social benefit and marginal social cost curves. Since there's no consumption externality, I pretty much already have my marginal social benefit curve. My demand is my marginal social benefit, so demand / marginal social benefit. And since we saw that the demand curve is P equals 12 minus Q, that's going to be my marginal social benefit. The biggest mistake people make is they say, since demand is my marginal social benefit, I can just copy down the 12 minus P here. That, for starters, doesn't make any sense because we know marginal social benefit depends on the quantity. So saying it's 12 minus P, which depends on the price, wouldn't really make any logical sense. So make sure you invert it and write it in this form of P equals 12 minus Q. That's demand, so that's also my marginal social benefit. Oh, don't want that. All right, 12 minus Q. My marginal social cost is going to come in part from my supply curve, my marginal private costs. So that'll give me Q plus 2, but now I have to add in the production externality. I know that is a negative externality, and it's $4 per pound. And the confusing part here, which you really don't need to remember anything except to use common sense, is whether I should add 4 to this marginal social cost or subtract 4. It's negative, so you might think I should do minus 4, but on reflection, we know two things. One is that the costs should be bigger, right? This is a negative externality. It should be making my costs bigger, so intuitively this doesn't really fit. Also, if we plotted it, we would see that the efficient quantity would be bigger because of this externality. That also wouldn't make any sense. So just going with common sense, we know to add this negative externality to the cost. It's a bad thing, so it's increasing the costs. And we can go ahead and plot MSC. If we simplify, it's just going to be Q plus 6. So it has a slope of 1 and an intercept of 6, and that is just 4 units above my supply curve. And now on my graph, I can label my Q efficient. That's where MSC intersects MSB. I don't know what this number is yet, but I can at least label it, and I can label my market quantity. I don't know what that is yet, but I can at least label it. So the next thing we're asked to do is find the efficient quantity. Unfortunately, I've done most of the work to get there. All you need to do is find where MSB and MSC intersect. So if I set that up, it's 12 minus Q equals Q plus 6. In general, I wouldn't try to do this in my head, but I need the space, so you can work that out, and you get 3. This quantity, efficient quantity, is 3. Sometimes people ask, should I also label an efficient price? And the short answer is no. There's no concept in economics of an efficient price. Economists, when they're talking about efficiency, care about social surplus. Efficient means you've maximized your social surplus. Social surplus depends on how much is produced, how much is consumed, who consumes it. It doesn't matter who pays how much for something, because if I pay more for a product, that's going to be good for producer, bad for me. If I pay less, it's going to be good for me, the consumer, bad for the producer, whoever that is. Either way, it's not affecting the social surplus, it's just transferring resources between two people. So the total amount of surplus just depends on the quantity. The price is irrelevant. so there is no efficient price. All right, so we've labeled our efficient Q. Just for the hell of it, we should also go ahead and label our market Q. So we can set QD equals QS, and we get that it is, I think it's 7. No, that's the price. It's 5. So what we solve QD equal QS, we get a price of 7 and a, which I guess I'll label the market price. The market price here is 7, and the quantity is 5. So we can see that the efficient quantity is 3, which is less than 5, so our calculations tell us that the efficient quantity is smaller. That matches up with what we see on the graph, where it's clear that this quantity is smaller than this quantity. All right, so continuing, we're asked, what is the deadweight loss without the tax? There's a really nice triangle already drawn in here for us, and I know that's what everybody wants to shade in. We've seen a lot of triangles like this. It's already kind of drawn in for us. It's just, you're just going to feel a real temptation to shade in that triangle and then find its area. Unfortunately, you'd be totally wrong. You have to follow the rule, and our rule for deadweight loss, to remind you, is find the tip. That's always the efficient point. Then find the base. That's the actual market quantity. And then shade between the two. I call it TBS. So our tip is going to be at this efficient point, 3. Then we're going to find our actual market quantity. That's 5, so that's here. And then you just, starting from the tip, shade in all this area towards that base. And we get this triangle for the deadweight loss. Do we have to calculate the size of it? I guess it says what is the deadweight loss, so we should calculate the size of it. So this deadweight loss triangle has a height of 2, that's a 3 minus 5, and then the base is this length here between MSC and supply, and we know that this gap is 4, right? It's just a constant 4 units all the way up, so we can fill in 4, and we get that the deadweight loss is $4. So there's $4 of deadweight loss if we don't have any kind of corrective tax in this market. That said, we know that you can easily do a corrective tax. You just set the tax equal to the size of the externality. Unfortunately, the externality here has a constant size of $4, so we just do a $4 tax. All right, moving on. Suppose that this country opens up to trade, and we can buy beef on the world market or sell beef on the world market for a price of $4. So we'll draw in our world price of 4, kind of between 6 and 2 here. And I'll label that PW. And then at this low price now, we can see consumers are going to want to buy a lot. We can plug in 4 into the demand curve to get that they want to buy 8 units, 8 pounds. We can see that at this low price, suppliers don't really want to produce very much. We can plug in the price of 4 and get that they want to supply 2 units from the supply curve. And then we'll import the 6 units that are the difference, right? If we're consuming 8 and we only produce 2 pounds, we'll have to import the other 6 pounds. We're asked, what is the social surplus now? I know you'll be tempted to try to do this like so with some fancy quick calculation or something, but there's really no alternative to building a welfare table. So we'll go ahead and do that. We have our consumer surplus, producer surplus, government, which is not involved here, so that we can kind of skip over, and then externality, costs or benefits. These are our 4 components, so we're going to sum them all up to get social surplus. So with trade, consumer surplus, we could label all the areas. If that helps you, I would recommend doing it. Here, to save time, I'm just going to outline all the areas and then calculate their size without, using little letters and stuff. Because ultimately, we want social surplus calculated and given as like a number. So eventually, you're going to have to calculate the size of the areas anyway. So consumer surplus, we're buying 8 units at a price of $4. So all the area below the demand curve and above that line, right above this line, our price of $4 is consumer surplus. So that's a pretty big triangle. It's 8 units by 8 units, so that's $32 worth of surplus. Ugh, that looks awful. Can I erase that? Oh no, it's stuck. All right, I'll work around it. $32. For producers, they're only producing 2 units, and they get paid $4. So that's a pretty low price and small number of units. So they only get this little triangle, but that makes sense. I mean, trade is pretty bad for them. It's a 2 by 2 triangle, so it has an area of 2, so that's $2 of producer surplus. There is no government here. For externalities, you could try to label the area on the graph and then find the area of that area you've labeled. I'm going to shade it in because I think a lot of people have a hard time with this, but then I'm going to tell you pretty much don't ever do that if you don't have to, because it makes things difficult. So the way you get the externality, cost, or benefit is you start at 0, you find the distance that represents the size of the externality, and then you just shade in that area between those 2 curves until you reach the relevant quantity. Here, it's production externality, so we shade until we reach 2, the amount produced. You don't keep shading until you reach 8. You'd only do that if it was a consumption externality. Then you would keep shading until it's the amount consumed. With trade, it really makes a difference whether it's consumption or production externality because we have both an amount consumed and an amount produced, and you need to shade towards the right quantity. So now we have this blue parallelogram. If you're good at geometry, you know how to calculate that area. I personally find it a bit of a pain. So what I'm going to do is just say, look, we produced 2 units. We know that the cost was $4 per unit. So then the total cost must be just 2 units. $4 per unit is $8. And then without having to shade anything in, I know that this cost is $8. And I know it's negative, so I'll put a negative 8 here. All right, so my CS was 32. My PS was 2. That gets me up to 34. Minus $8 brings me down to 26. So the total social surplus was $26. Finally, a last question that we're asked, and this is really where the policy application comes in. We can see that the external costs are pretty small because of trade. We don't produce a lot of beef, so thus we don't produce a lot of greenhouse gases, and the damage from the externality is limited. And the question is, if we open up to trade, and maybe even furthermore start taxing production, then we could get production even less than 2 units. We could get it all the way down to 0 if we wanted to from taxing it. Is that actually going to reduce worldwide pollution? And the short answer is, if we continue to consume $8 worth of beef, which we will, even if we tax production, somebody somewhere has to produce that beef, which means somebody somewhere is producing pollution. So on a worldwide scale, this is going to do absolutely nothing to reduce pollution. And this is part of the reason why you see, the Obama administration and most state governments are kind of reluctant to do a carbon tax or to do much in terms of trying to address global warming if they can't get other countries on board. If Massachusetts puts a big tax on, producing cow meat in the state, you can go to any other state and produce and not have to pay that tax. And then there's still a lot of pollution being produced, still contributing to global warming. People in Massachusetts will still be eating beef. So really the tax did absolutely nothing. So if you're going to do a carbon tax, you really want to have it not just the US alone doing it or the US and Europe. You kind of have to do things on a global scale. Otherwise producers will just go to the few countries or many countries that don't have a tax. So that was our policy application. There's going to be 3 more videos with reviews that try to take a situation that's like policy relevant and kind of fit it into the models of these chapters. So giving you a nice review of the concepts while at the same time doing some neat applications.